Hello, Mr. Mailer here, online math teacher, and welcome to my channel. Today we're going to be continuing my video series on hypothesis testing, and in particular we're going to look at how to do one sample z-tests for population proportions. So if you find this video helpful, consider smashing the like button, subscribing, let's go. So this is going to be part one of a two-part video series. This first part I'm going to focus on doing an example with a one-sided alternative hypothesis, so let's jump into it. So if we are going to do this, we are going to use the four-step process for our hypothesis test here. And it is going to follow the same pattern that you used for confidence intervals. We're going to use the state, plan, do, conclude criterion. So under state, the four things we're going to be looking for are state our hypothesis, the significance level we want, any parameters you're going to use, as well as the sample statistic. In the plan phase, you're going to state what the inference method you're going to use is, as well as check your conditions. The do phase, if the conditions are met, perform your calculations, and then that's going to be your test statistic and your p-value, and then finally in your conclude phase, you're going to interpret your results always within context. So let's jump into an example. So, a local grocery store, you monitor the quality of fruit delivered for sale. If the store determines that more than 10% of apples are bruised upon arrival, then the truck will be sent away to get another load from the supplier. Otherwise, the truck is unloaded and the apples are put out for sale. To determine the proportion of apples bruised, the store takes a simple random sample of 350 apples from the truck. Of the apples selected, 50 are bruised. Based on this observation, the store carries out a significance test with a level of 0.08. What should the store conclude? So we're going to carry out a hypothesis test now. So we're going to start with the state phase. So we are interested in performing a hypothesis test with a significance level of 0.08, with our null hypothesis being that the proportion of apples that are bruised is 0.1, with the alternative being based on our sample statistic, we think that more than 10% might be bruised. So P is going to be greater than 0.1. And again, P is the actual proportion of apples that are bruised in this truck. And our sample statistic was 50 out of those 350, a simple random sample of apples were bruised. So this is our state phase. Now let's go to the planning phase. So we need to choose our inference method and check our conditions. So our inference method is going to be a one sample z-test for population proportion P. And our conditions are going to be the same as they were for confidence intervals. So do we have randomness here? So yes, it was a simple random sample of 350 apples. Randomness is always important because it lets you take your observation in your sample and generalize it to a population. So this is inference. Then we can move on to independence, which in any time you have a simple random sample, it's going to be checking the 10% condition. And 350 apples is definitely less than 1/10 of all apples that are going to be in a truck. You're going to have a lot more apples than that. So the 10% condition says taking a simple random sample is fine, and we can use our standard deviation formula for proportions. Then do we have normality? Well, assuming our null hypothesis is true, which is what we do in a hypothesis test, the expected number of bruised and non-bruised apples are going to be 35 and 315 respectively. Both of those are greater than or equal to 10, so yes, we have the large counts condition being satisfied, which means we can assume that the sampling distribution of sample proportions is approximately normal. So we have our three conditions met. So now we can move on to the do stage. So here we find our test statistic and the p-value. When we're taking a simple random sample of size n to try to find an unknown population proportion, and we've assumed the null hypothesis is true, the z statistic is going to be the sample statistic minus your parameter divided by the standard deviation of your statistic. So you can see that formula is what I put right here. And once we have that, you can either use a table or technology to find the p-value by calculating the probability of getting a statistic that is this large or larger in the direction specified for your alternative hypothesis. In this example, since we want to know what percentage more that are bruised, so we think that maybe more than 10% of our apples are bruised, we're going to be looking at this picture for the far left here. So this far left picture here. So we can now go and actually do this. The first thing we do is we are going to take our information and compute that z statistic. So we get a z score here of 2.67. So now, based on this normal distribution for our sampling distribution, we are going to go and look at this normal distribution. So we're going to standardize it, and we can go to our table and we find that the area under the curve to the right of that z-score of 2.67 is about 0.0038. So this is all you need to do in the do phase. Once you have that, you can go to your concluding part. So we're always going to compare that p-value to your significance level. And in this case, since our p-value of 0.0038 is less than the significance level of 0.08, then we should reject the null hypothesis to accept the alternative. In this context means that the store should accept that more than 10% of the apples in the truck are bruised, meaning that they will send the truck away. The truck's going to have to come back with a new load for us. So if you're wondering what that might look like if you hand wrote this problem, because you probably won't write a PowerPoint, this is a handwritten solution I produced. It follows the state plan do conclude process. So I hope you found this video helpful. If you did, like I always say, smash that like button, subscribe, and have an awesome day.